Firstly, in laws of motion, the main concept is force. Force is known as a pull or a push or an object which changes the state of a body. Force always acts in pair and on different bodies. And forces are of two types, contact force and non-contact force. In the chapter Laws of Motion, Newton has mentioned three basic laws. Newton's first law of motion is if a body, first law, if a body is at rest, if it wants to be at rest, if it is in motion, it will continue to be in motion until an external force acts on it. In Newton's first law of motion, inertia is also there, and inertia means laziness in simple words. In Newton's first law of motion, F external, if F external is equal to 0, then acceleration A is equal to 0. Moving on to the second law of motion. In Newton's second law, the Newton's second law is the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. In the second law, there is also mentioned momentum. Momentum is equal to mv. And in the second law of motion, F external, if then F is equal to ma in the same direction. Moving on to the Newton's third law of motion. The third law is to every action there is an equal and opposite reaction always. And in third law, it is also said force always acts in pair and on different bodies. Moving on to the application of Newton's laws of motion. In the first law, we can find tension in the string. The sums which are related to find tension in the string, we can find that. In Newton's second law of motion, we can find acceleration, which is application of laws of motion. In the second law, is equal to net F upon m. In Newton's third law of motion, we can solve the problems regarding to gun shooting and that. Moving on to free body diagrams. Free body diagrams are the diagrams which show us the force act on an object, externally force act on an object. The first example is there is a right angled triangle in a right angled triangle. Gravity acts towards downwards. Here is an angle theta. Gravity acts downwards. Then again, g cos theta acts in this side and it makes an angle theta. And then this is known as g sin theta. In another diagram, in an inclined plane, This is the angle theta. Then here acts the r cos theta, and over here acts r sin theta. System. In system, there we can take an example and then move on. There are two blocks, one upon the other, M1 and M2, which are joined to another block named M3, and the force acts towards here. So to solve such kind of problem, we can use the formula as acceleration is equal to F upon M1 plus M2 plus M3, because we can consider this whole system as one system, and then draw a diagram as M1 plus M2 plus M3, and the force is acted over here and the acceleration moves in this direction. So using this formula, we can solve such kind of problem. In the pulley system, we can first draw a diagram. M1 and M2. This can be solved by the formulas using acceleration is equal to solve this problem by using the formula A, acceleration is equal to G bracket M2 minus M1 upon M plus M1 plus M2. And to find tension, we can use the formula T is equal to 2M2 M1G upon M1 plus M2. Moving ahead to pulley tricks. Pulley trick. To solve such kind of problems, we can use these tricks. V1, V2, V3, V2. We can use the formula as Vc is equal to V1 plus V2 upon 2, V3. In such kind of problem, the velocities must be in the same direction. So we can use this formula and then solve this sum. Moving on to inclined plane. For an inclined plane, this is an inclined plane and here is the block. So to measure this kind of sum, on this block, mg acts downwards and n acts in this direction. And then here acts mg cos theta, and over here mg sin theta, and here it makes an angle of theta, and this is N, normal force. And in this the formula is F external is equal to mg sin theta, then MA is equal to mg sin theta, then M and M get cancelled and A is equal to G sine theta. So now moving ahead. Motion. Constant motion. In constant motion, for a moving pulley, if the pulley is moving, if pulley is moving, if pulley moves, it will be x, and if the string is released, it will be as 2x. Moving ahead on heavy rod problems, the diagram will be, this is a rod, a heavy rod, and here is the block. This is M, this is the length, and here it is the point C, here is the point A, and here is the point B. To find tension in A, TA is equal to mg. To find tension B, the formula will be M plus M by 2 bracket G. And to find tension in C, M plus M G. So by using this, we can solve a problem of heavy rod. Moving on to normal reaction. A normal reaction always acts opposite to contact force. This is meant by normal reaction. The next topic will be acts opposite to contact force. Topic: mass versus weight. In this, there are three situations. In the first situation, this is a lift and a man is standing in the lift. The mg will act downwards and acceleration will be 0. In such condition, if acceleration is equal to 0, then n is equal to mg. In the second case, if a man is in an elevator, mg is acting downwards and acceleration is acting upwards. If acceleration is upwards, then n is equal to m bracket g plus a. In the third situation, if a man is standing in an elevator, mg is acting downwards and acceleration is also acting downwards. If acceleration is downwards, then n is equal to m bracket g minus a. And in this situation, the mass of the second B case will be the more as compared to the others, and B is greater than the situation A, and A is greater than C as compared to their masses. Next, string and spring. String means only pulling force transmits force. And in spring, pulling and pushing force can be stored and also can be transmitted. And in string, only pulling force can be transmitted. Next is spring force. Spring force is equal to minus k delta x. Delta x is equal to mg upon minus k. In this diagram, is known as x, and k is the spring. The next point, combination of spring. One is parallel and the other one is in series. The parallel one is equal to k1 plus k2 and moving on. And in series, it is 1 upon kf is equal to 1 upon k1 plus 1 upon k2 plus moving on. The next thing is pseudo force. Pseudo force is the product on the mass of the same body and the acceleration of the frame of reference. And pseudo force is also known as fictitious force. Frame of reference. There are two frame of reference. One is inertial and the other is non-inertial. The inertial one is an observer is either at rest or moves with constant velocity. And the non-inertial is observer is always accelerating with some acceleration. An example of inertial frame of reference is a train is moving with constant velocity. And an example of non-inertial frame of reference is a turning car with constant speed. Next is constrained motion. In this diagram, the block and a moving pulley is there. In this, V acts towards this direction and in the upward direction. That's why VB, that means the velocity of the block, will be V. In the second example, the block and the pulley if velocity is acting towards this direction, then the equation will be VB. That means the velocity of the block will be root 2V. And in the third case, if both move with velocity v, then the velocity of block, both in the case of the block moves in velocity in this direction and the pulley in this direction. So then the velocity of block will be root 5v. Moving pulley.